Okay, we are live. How is everybody doing across platforms? Good to see the community on a Sunday evening. It's Sunday evening at my place. You might be joining from some other geography, but I'm guessing it's most likely Sunday. So thanks a lot for joining on this weekend. And a warm welcome to anybody who's watching this later on as well. So I'm Mudit. I'm one of the founding members of DeFi. We are a global community of AI enthusiasts. So basically, what we do is we provide a ton of free educational resources in the form of boot camps, live expert sessions, courses, with the help of contributors like Avinash, who will be with us very shortly. He's in the backstage. I'll loop him in a couple of minutes. Today we'll be talking about, we'll be discussing a very rather interesting topic, which is around deploying scalable ML models. Why is it important? Because if you are a data scientist in the industry, you would know that it is one of those pain points where most of the most of the companies fail to they may be able to develop a model, but they may fail to deploy it because they may not know the best practices, or even if the best practice is second mile, I think the first thing that they may even not know is how to even have a process to deploy scalable models, what are the tools that you should use, and so on and so forth. This is not as In this particular session, we'll be talking about deploying scalable ML models using Kubernetes, TensorFlow Serving, and Flask API. Okay, and today, as the speaker, we have Avinash. As you might know, if you're new to DeFi, let me give a very quick intro on that front. So we host contributors on a regular basis. These are seasoned data science leaders in the industry who are willing to give back to the community. They generally put in a good amount of meticulous efforts to create a presentation and to deliver a session that helps you in gaining hands-on insights when you have to deploy these learnings in your real life world. Okay, so Avinash is with us today. Generally we have these sessions on Saturdays, but today, yes, yesterday also we had a session. This is an exception. We're also having a session on Sunday. So if you're joining us live, as I can see, there are people across platforms. So thank you for joining in. We'll dive right into the session. Before I loop in Avinash, let me give a very brief introduction of him. He's a manager of data science at State Bank of India. For those who do not know what State Bank of India is, it's India's largest bank. And Avinash personally comes with an experience of 9+ years in model building, implementation from scratch to production. And he has worked in a plethora of industries and use cases. So these include things like e-commerce, CPG, retail, FMCG. CPG is something that we have discussed in the past as well, as you might know, and several other sectors similarly. And currently, of course, State Bank of India being a bank, he's right now in the BFSI sector. Apart from that, he also manages a community and newsletter through which he tries to impart knowledge on a regular basis. So that's a brief about Avinash. Let me quickly loop him in for you all to learn from him. Okay. Hi, Avinash. Thank you for being with us today. Glad to have you on the show.
Hi, Mudit. Thank you so much for hosting me. Thank you so much.
Oh, the pleasure is all ours. Let me just check. I think if we are live on, okay. I think okay. I just got a comment. Probably could you just give me a moment? I think probably we are not live on LinkedIn. Sorry for the community members who are joining from that platform. I just got a notification on the platform saying that this seems to be an issue with LinkedIn per se. I'm not sure. I'm just checking it out.
Mm-hmm.
Just a moment. I'm sorry for this.
No problem.
Let me ensure that nobody is missing out on this opportunity, since there are a ton of people who must be waiting there. Let me just see it. Okay, it still says waiting for broadcast. Um, okay, just give me a moment. I think okay, I do not know if I should. Okay, this is really tricky for me. Let me just go there. Okay, okay. I think we can start off the session. I am putting a comment on LinkedIn for all the people who are waiting there. There are over 212 attendees there. I do not know why this is happening. This is the first time. I think I'll put a comment there for anybody who must be waiting there to join on YouTube or any other on DeFi maybe. So yeah, maybe we can. Yes, I just got a comment. Yes, yes, yes. It is started. Okay. Cool. I think Avinash, you can probably take this forward. I'll put in the comment as well. Maybe you can start off with an introduction, and by that time, I'll drop a nudge to the community on LinkedIn. Does that
Sure.
sound? Yeah.
First of all, am I audible perfectly?
Yeah, yeah, it's perfect. Yeah. Yep.
Okay, okay. So thank you so much, Modit, for hosting me and giving me this opportunity to interact with your community member. And before I go ahead, congratulations to you and your team. I got the news like you people have received some kind of initial stage funding. So congrats for that.
Thank you
Uh,
so much,
so,
Avinash. Thanks. Yeah.
so yeah, my name is Avinash Mishra, and currently I'm working in State Bank of India as a manager data scientist. So I have more than 9 years of work experience into data science and machine learning, as said by Mudit before, into various industries like CPG, retail, FMCG, and currently associated with BFSI sector to the largest bank of India. I think that's it. Maybe we can start the session. Mm,
Yeah, sure. We can do that. Yeah.
okay. Mm, I'm just checking whether my screen is visible over there.
Okay. I think, yeah. Meanwhile, while he's checking,
It's visible.
I have a quick announcement to make for people. First off, I'm not sure why this is happening. I'm just quickly putting out a comment on. There are a ton of people waiting on LinkedIn. For them not to miss out on this opportunity. For those who are already live on YouTube, if you can hear me clearly, please drop in a comment so that we know that yes, um, the community members joining from YouTube are able to hear me clearly. We really do not want you to miss out on this session, so please let me know. Meanwhile, let me just do this. Yeah. Okay, let me just check. Give me a moment. I'll probably check. I'm sorry for anybody who's waiting. I'm sure there are people waiting out there. There are people watching us on YouTube. Please give me a moment. I'm trying to resolve this. I think there is, yeah, okay, fair enough. Okay. Okay, I can fortunately see some comments. Yes. Yes, 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 yes. Okay. I think Avinash is also he has, yeah. Avinash, can you try if you can, maybe share your screen? Can you just experiment with that once?
Yeah, yeah. Sorry, man. Actually, I don't know why I got dropped off.
Oh, okay. Okay, no problem. Yeah.
Can you guys see my screen?
Yes, it is visible. Yes. Great.
See, is it visible now?
Yes, it is visible. Yes.
Okay, perfect.
Great.
So yeah, without much further ado, let me start this session. So yeah, I'll be discussing about model deployment on Kubernetes by using TensorFlow Serving and Flask API. So moving ahead, this is a kind of outline that I'll be covering today. So since this task is about the post model development, so it means like our model is built, and then after we are in a stage of like productionizing it. So before that, we have to ensure because we are talking about deploying it on a Kubernetes. So we have to ensure the Docker is properly up and running. It can be in your local machine or it can be any cloud instance, whatever you are using. And then, as I said before, it's a post model development task. So I'll not be focusing more on the model building side. Rather than that, I'll be focusing more on how to serve any specific model using TensorFlow or FastAPI. So for TensorFlow, actually, of course, we have to get some kind of model. So it can be custom model, or you can get some kind of uh, let's say pre-trained model. But for today's session, what I'm going to do is like for TensorFlow serving case, I'll be using ResNet, and for fast API, I'll be using a language detection model. And third point is like I'll help you guys to understand like how to containerize any models before we dump into Kubernetes cluster, and then setting up Google Kubernetes Engine cluster. You can do it on your local machine as well, but I think because we are talking about the production, so it can be maybe Google services using GK or AWS or Azure services of cluster management. You can use any of the service. And then last, we'll after creating the clusters and all, I'll help you guys to understand like how to deploy the models at scale. So first thing first, we need to check the Docker setup, and for that, there are two commands we can check on Linux platform, like ps-ef grep docker or systemctl status docker. So it will help you to understand your Docker setup is running. Moving ahead. So yeah, actually today's session, how it is going to be look like is it's quite hands-on in terms of like a lot of snippets I have put into my presentation. So with the proper hands-on experience of how each and everything should be deployed and how things works. So yeah, please bear with me. So moving ahead, as I said before, like we need to get the model, and for that, for TensorFlow serving case, I'll be using ResNet. So uh, I have created one of the project which is called as a model serve K8s and TensorFlow. So inside this, I created one more folder called as a model, and inside this ResNet is another folder. Then I did the curl, and I have downloaded here. You can see ResNet, and then I have exported it. So because I have downloaded the image, so we can check by running the Docker images command, and we can see here like TensorFlow serving latest version has been downloaded. So yeah, let me tell one more thing. Here the thing is, I downloaded the model first, and then after actually what we have to do is we have to download the TensorFlow serving, because TensorFlow serving is something model is downloaded means like it's a Docker container, and then that container has to be served somewhere. So for serving, TensorFlow provides a very nice thing which is called as TensorFlow serving, which is a production ready Docker image, and we can get it like from the Docker Hub. So this is the command for that. If you want to get the CPU specific command, so TensorFlow serving latest is there. For GPU specific command, you can use the latest hyphen GPU. So it will give you the GPU version of it. So we have this container of ResNet, which is my model, and now we have this serving image. Now the thing is like for this serving, actually the entry point of there is an entry point for this serving image, and the entry point is located into this location, which is like user bin TensorFlow serving hyper underscore entry point dot sh. So it has by default it runs well if you are serving only one model, but if let's say if you want to serve more than one model, then we can edit it, and ideally it looks like this, and I have edited for my own customized version. So it will provide you a more control on port and like various kind of ports that you want to open up, and it will also help you to provide the name of your model. Like in my case, it's a ResNet, and you can set up your path. So this is one of the reason you can say you can, when you are planning to put your TensorFlow serving for production, then you can edit simply this file like this. So this is just an example of it. So after this, actually you can see here Docker images, as I said before, like because I have cloned the CPU version, so TensorFlow serving is there. Now my model is ready. I have downloaded it, and now it's ready to serve basically. So TensorFlow serving is going to help us regarding this thing. And as per the explanation on GitHub, it's pretty flexible, as I said before, and very high performing serving system for machine learning models. Now, before I jump into putting it for serving, I need to mention one more point, which is about let's say if there is a case, of course, it will be the case where you want to serve more than one models. Then in that case, what you are going to do is you need to edit this model.config file, and it looks something like this. Here you can have a name, you can have your base path, your model platform, whether it's a TensorFlow or any other thing. So it will help you to change the configurations like this, and by using this thing you will be able to serve multiple models. And if you are using models.config, then definitely you have to change that entry point file that we discussed before, which is this one, like the TensorFlow serving entry point dataset. And what you have to do is, like, you need to provide this model config file equals to the path to this configuration file. So this is the scenario when you want to serve more than one model, uh, which is ideal scenario. Of course, we have to do in production, in real life, we have to do not just one model, more than one model has to be served. So this is something has to be played also. Now moving next, so far what we have discussed, like we have downloaded our ResNet image and place it to a folder. We have downloaded the Docker image of TensorFlow serving. We have played around with entry point .sh file and change it a little bit as per our convenience. Now moving ahead, what we are going to do is, like, uh, we'll uh, we'll do some of the changes, because entry point.sh has comes up like not entry point.sh only, but basically this TensorFlow serving comes up with some kind of their own thing. So we have to, of course, that is just a container, right? So we have to bundle up our model inside it, and once we bundle up our model inside it, then it should be ready to serve. So what we have to do in that case is, uh, we can just spin it up. So we can start the container image, which is like TensorFlow serving. It can be old version, it can be latest version. In our case, it's a latest version. So this snippet I used pretty old. So you can just put it simply latest or ignore it, because by default it's a latest entry. And then our ResNet model that we have downloaded from whatever the location it is placed. So from that location to Docker, using Docker CP command, you have to put it here, because this is the default location where model goes inside the TensorFlow serving. So you have to copy from your local inside the Docker container. And next thing is basically, as I said before, we have modified the TensorFlow serving entry point.sh. So if you have modified, you can simply replace it to this location, which is inside the container user bin TFserving entry point.sh. This is the location basically. If you have not modified it, you can just comment it out. You can leave it as it is. So we have, after spinning up the container, we have copied our model inside it. We have copied the TensorFlow serving entry point. Now simply we can commit, because we have done some of the changes inside the Docker image. And after committing, we can, it's up to us, we can simply leave it or just keep it as it is. And then the idea is, like, after committing, we have to we can maybe push it to some kind of container registry, like Google Container Registry or Docker Hub. But let's say if you are working on local or any of the cloud instance, you can for a time being, you can simply kill it and then again spin it up. And there are two ports. 8500 is for gRPC, and 8501 is for REST API. And yes, when so we have, apart from that, we have so let me break it down so that it can be easy to understand. So now container is up. You have done bit of changes. You have copied your model. You have copied some files, and you have committed it. Now you need some kind of, because your model is there, and in previous command, like over here, you have again run the same container after commit. So it's up. Now it's time for us to check whether how to basically check uh, our container is serving properly or not. So what we can do is, in that case, actually, this RESTnet client, we need to provide some kind of client APIs that can interact. So for that, actually, this is one of the Python file. And using that Python file, basically, when we run the Python, this command, and basically this is the Python file, which will help me from the client side to interact with my container image. And to do the gRPC call, I have to mention the port 8500, and to do the REST API call, I have to mention the port 8501. And I think this image I inserted when I already deployed it to a kind of Kubernetes cluster. But if you have not done it, then what you can do is like, you can simply leave the IP, and it will spin it up on your that local machine or that cloud instance wherever you are working on. And ideally, you'll see the gRPC response time is very faster as compared to REST API. So you can see it's zero point 0.5 is the average taken time, and here is like 3.2. So that you can also, I'll show you to like how to verify it later on also, when we'll deploy these things into Kubernetes. So moving ahead, when, as I said before, if you have just spin it up on your local machine, so on 8051, which is our REST API port, you will see the status is okay, and you'll see some kind of version, which is nothing but inside your this thing, your model file. This is the kind of like entries there. So that will give you information about, okay, your container is ready, and it is serving properly. As I said before, we have seen like gRPC is quite faster, and I'll show again when we'll deploy it to Kubernetes cluster. So let's say if we are using the GKE, which is a Google Kubernetes engine, then in that scenario, what is going to happen is, uh, when let's say we are running, when we'll run the deployment over there, then it will ask us from where it has to copy the Docker image where that comprises our model. So for that perspective, actually, we have to push our model either to GCR, which is Google Container Registry, or we can put it to enterprise version of Docker Hub. And you can provide your whatever name you likes, and you can provide some kind of tags. So like in my case, I have pushed it to a Docker Hub just for the sake of simplicity, but it can be easily done for a GCR registry as well using this command, which is like docker push gcr.io TensorFlow Serving RESTnet. So now we have tested like our model is serving on Docker, and its response time is good on gRPC as compared to REST API call. Now the time is like how to deploy your model to Kubernetes cluster. So to do that, you can of course log into a Google Cloud Platform, and you can simply manually create their your cluster. They do have started supporting this kind of autopilot creation of the cluster, but you can manually create it. But if you are somebody who likes to work from the terminal itself, then what you can do is like you can simply download two things. One is like Google Cloud SDK, and another thing is like to manage the Kubernetes cluster. You also need a kubectl. So we have to download it. I mean, there are plethora of pages on internet. You can just go and find like how to download these things and set up. My recommendation is like simply just follow the whatever is being recommended by authentic sources. So setup to set up the Kubernetes. So first is like, let's say you have downloaded the Google Cloud SDK and kubectl, it's properly done. Now, first thing is we are going to do is like we have to log in. So by running the gcloud command, you will be able to log in, and it will basically what we are trying to do is like it will open up a kind of a web interface, and there you have to provide your authorization ID. Next thing is, let's say after login you want to create a project. So in my case, I have created a project inside a GKE, which is called as a Avinash Serving Model hyphen project. So this is the command, you can use it. It will help you to create a project. And then you can simply set default project, you can say. So in my case, I have multiple projects. So you can set one of the project for what you are working as for the time being. So like in my case, I have set it up Avinash Serving Model project, and this is the command. You can use it to set it up. Moving next, once the project is set up, you can check the projects list. The multiple projects will be shown. I have just shown this one for the sake of security, but it will have multiple projects IDs. So one more thing you might have to do is like not might basically you have to do is like you have to authorize the Kubernetes API. So for that, whatever project you have been mentioned, you have given. So like in my case, Avinash hyphen serving model hyphen project. So if you go there, you will be prompted with this kind of screen where you have to press simply enable, and when you'll do that, you'll see like no cluster is there because you have not created anything so far. So what you can do is like to create a cluster, you have to run this command from the terminal, and from this interface also, if you go like create a cluster, I think this Google Cloud Platform is also pretty interactive, so you can create clusters manually. Like here also, you can press this button. It will give you two options: standard creation of standard cluster as well as the autopilot mode cluster. But I like to create it from gcloud command. So by running this command, I am trying to create actually 2 nodes cluster. So number of nodes you can mention, and you can specify zone, disk size. You can read more about all these things on this Google documentations. And sometimes you might get zonal quota error, but it's only because if you are using some kind of, let's say, trial version or something. But if your company has already provided some kind of enterprise support of it, then this should not be the case. Yep. And then you can connect to the cluster, of course, using this command, using gcloud. So you have created the cluster. Now it's time to connect to the cluster from your local system. Whenever I say local, it means like wherever you are working on. It can be cloud, it can be your local machine. So when you connect to the cluster, then after that you can check number of nodes that you have created before. So you can see the 2 nodes has been created, and you can see using the kubectl get nodes command. Then moving next, now we have created the cluster. So cluster is there, and our Docker was serving before that we have seen using gRPC and REST API. Now how to deploy things to Kubernetes. So there are 2 files we can create. One is like deployment.yaml and service.yaml. So the idea is you can run using kubectl apply -f deployment.yaml, and same way for service.yaml. And when you'll do that, and after that you have to run one command called as a kubectl get service. So what you're doing here is like deployment is basically nothing but it will spin up your Docker image. I'll show you in the upcoming slides. And service is for mainly for the load balancing. So when you run the command to see how many like your service is whether up or not, so by running kubectl get service, you'll see it might take some time to to show the services, but it will give you some kind of external IP as an endpoint. So in my case, like this is one of the IP, but in your case, it can be anything else. So by using this thing, you can interact to your cluster. So like you can see the same IP address like 34.69.14.25. And if you follow this kind of, so this is the REST API port, that is what I mentioned before, like 8500 is for gRPC, 850 is for REST API. Then you can see the service is properly up and running. Then again we can do the same thing because this is the port now we have. So for gRPC we can never command on 8500 port, and for REST API we can run it on 8501, and we can see the same, like here gRPC response is pretty fast, and REST API is little bit slow as compared to gRPC. So if you're building, let's say, microservices for your company, in terms of a lot of things which is being internally utilized, or even for the outside, my recommendation would be like focus on the gRPC mechanisms. Now, as I said before, let me go back to two slides to explain. So as I said before, like I was deploying on Kubernetes by running the kubectl apply command for two files, deployment and services. Actually, it's always very painful to manage these YAML files. So what you have to do is, in that case, this Kubernetes provides a very nice tool called customization. And let's imagine a scenario like where you have your production system and you have your staging and development environment. In that case, what you can do is, um, you can, inside your project, you can create something like this. Base is for production, so inside the base you can create customization.yaml. You have to write it, and deployment.yaml and service.yaml. These two files that I explained before, you can put it inside your base, so it will be the part of your production system. Now inside overlays, which is nothing but staging and development, so inside that you, of course, customization.yaml has to be there, and you can put any other kind of configuration, like YAML configuration files that will serve your staging and development. And it becomes quite easy to use the customization. So let's say customization file is there. So as I said before, in this slide, so customization.yaml is there. Now before, how we used to do is, like we used to do the kubectl apply command. Now for this customization, what you have to do is you have to run this command, which is called as the kubectl apply -k. So -k means like it will understand, okay, we are going to run the customization, and after running this, just by running one command, your cluster will be ready to serve. So yeah, so far, yeah, I mean, after that, your application, whatever ResNet model we have cloned, it will be properly deployed to Kubernetes clusters with two pods. And then as of now, whatever informations I have given, it seems like pretty manual. So what you can do is like you can also Dockerize it. I'll explain the Dockerization mechanism by writing a Docker file for the FastAPI stuff. But so far, that's how you can basically put your TensorFlow images to Kubernetes. Yeah. So from here onward, I'll explain about how to put how to deploy the FastAPI base FastAPI wrapper of your model to Kubernetes cluster. So 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 let's say this is one of the project structure that I have created, and this is a kind of, you can say, the one of the standard project structure you can follow for your project as well. So basically, inside the models, you can put your trained binary files, which is supposed to be served. In case of TensorFlow or PyTorch, it can be anything else, like a .prod file, those kind of things. And if if it's a kind of, let's say, a directory, like usually TensorFlow provides the trained models goes into the directory, not just in a single binary file. So in that case, what you can do is like you can zip it. You can simply zip it and then use it like this. And then requirements file, requirements.txt. I think people are already knowing these things. And then inside the source, actually, I have created two more directory. One is app and one is ML. So inside the app, I have written app.py. So this is one of the best practice you can say, and routers.py. So from app, I'm going to call the routers, and routers will call my prediction method. So prediction is basically written inside the ML. So inside the source, there is two main, app and ML. Inside app, we have app.py, routers.py, and inside ML, we have predict.py. So as I said, from app is the main entry point. So from here, it will be called, the router will be called. So router is on my right side. So router.py is basically inside the predict method call. This is basically, you can say, the space holder. Based on your project, or based on your like the coding style, you can change it, but the idea is pretty much similar. From app to call router, and from router you can call the basically predict method. That is a standard practice. So from this predict, actually, you can see here I'm calling this model, and model.predict is being called. So model is defined somewhere into my predict file. So this is my class, model class, which I have imported into this router.py file. And from here, you can see this is the model, and inside this there is a predict. So here I have not given anything like any specific code. Of course, when I was deploying it, and when usually I deploy anything, we have to write very uh, defined kind of call and methods for prediction. It depends on like sometimes pre-processing, transformations, predictions, everything is has to go there. But this is, as I said before, this is more like a placeholder, so you can use this template to create your own project when you deploy the FastAPI applications using Docker and Kubernetes. So we have uh, we have our app.py file and router.py file and models.py file. So in that case, what we can do is like to dockerize, you can start with scratch, like just getting the Python and everything. What I did is like I followed one of the recommended practice by the FastAPI. So which is like this UVCon and GUnicorn. You can simply use. This is the kind of ready to use image that you can use to serve your FastAPI application. Then requirements.txt file, that's what we explained. So you have to just copy this file to somewhere into the Docker, inside the Docker, and somewhere means like inside the app and requirement.txt, because this is where it will be placed to help you run it further. And then simply, this is nothing but just a requirement.txt file. It's a run command. I'll show you in my code editor. I think it will be much better. And you can expose some of the ports. So like in my case, I have exposed it to 8000, and then you can copy your .app to the location of app/app. So here 2 times app I'm using, because by default you'll be landing to app and you are copying app, so it should go inside the app. So that's the reason we have to put 2 app. um, Apart from it, simply you can follow the mechanism of like how to create a proper Docker files for any like applications. And if you just uh, play around with it, you'll understand like what I'm talking about. So After that, your Docker file is ready. You can build it, and after building this thing, if you simply run it on 8000 port, uh, it will be first live on your local system. So here you can see the health is okay and model version is also there. So this is coming from the file actually. I'll show you maybe in my source code. I think it will be much better. So So this is the Docker file I was talking about, and here you can see the structure of this thing. Inside the app, uh, I have this my model, and this model.py is there. So this is the structure, and that uh, you can follow, depends on your project need or something. One one another best practice is like whenever you're writing Docker file, please write the Docker ignore as well. So you can simply Google about the specific products, and uh, you can put the necessary ignore files over there. And as I said before, since we are using UVCon and GUnicon based fast API, already ready to use image. So inside the requirements.txt, I'm not putting many like many more things. I'm just putting like, let's say, if I need just scikit-learn, that's okay, or TensorFlow, whether CPU or GPU, that's okay. But in my case, I don't need it. I have just created scikit-learn. Just inputted the scikit-learn base information, because TensorFlow CPU is not at all used in this project. But yeah, basically the idea is here is like you can put whatever you want, and then that should be copied to your container as well, like using this command. Let me go back to presentation here. Yeah, now talking about the deployment. So deployment is also a same. Um, we did, because now we have the Docker, so we are at a stage where we deployed our TensorFlow image before. So here also now we are at a stage where our Docker container is ready. So deployment is pretty much same. We need to write two files. One is like deployment, which is here, and one is like the service. So as I said before, like the better way to write these things and manage these things are like using customization. And let me show with the help of this thing is my source code. So I have written one customization. So inside this customization, basically I have given the project name, which is like ML Fast API K8s app. This is something. When you run the Docker container, you can provide any of the names. So this is exactly same. And inside the resources, deployment.yaml and service.yaml, these two files I'm going to use, so I have mentioned it here. So inside the deployment.yaml, you can see API version kind. It will be deployment, because this is a deployment for the sake of deployment. And in case you are using it this is going to be for the REST API, so you can define other any other informations, like, okay, I have written it here gRPC, but actually it should not be there. It should be like basically for REST API. So this is for the REST. And services is nothing but a load balancer. So inside that, the kind has to be service, which is quite important, and other things are you can simply follow this of my deployment and services file. You will be able to understand. So here you can mention the service, like app name that you want to run, and you can simply write my app name is this one, and towards the end I like to add a suffix like hyphen service or hyphen deployment, depends on whether I'm writing deployment.yaml or service.yaml. And once you do that, then the same command we have to run, which is nothing but this thing, kubectl apply hyphen k customization. So basically hyphen k, after that you have to write the customization.yaml file, and after that your container will be deployed to Kubernetes. And yeah, one more thing I forgot, which is like mentioning the hub from where, like when we are saying deploy to Kubernetes, from where it will copy the image. So ideally, what we mention is like here you can write something like let's say for the sake of example, I can write it like this. You can write something. Let's say in my case Avinash 02 is my Docker hub, and then user ID, and then you can mention something like ML fast API K8s. So this is something that should be present in your Docker hub, or you can write a Google container registry URL wherever you have deployed your image. So from there the cluster will pull it up, and there is an image pull policy. Since if you have simply put it on a local, so you can just mention this thing like if not present then only it will pull. Another thing is like you can mention here always. So whenever this deployment will be up, it will pull the image, then only it will start serving. So yeah, that is the important thing I wanted to mention. And it will be the best part of this fast API is like it deploys. Of course, your model will be deployed, but if you put something like on the top of with the help of URL, if you put something like /docs, it will provide you some Swagger UI. So to know this URL, you have to run the same command like the kubectl get services. It will tell you what all services are there, and what is the IP address, external IP address on which your model has been served. Your model is being served on Kubernetes. And yeah, from here you can play around. You can do whatever is there. Like it can be deployed, and it can be consumed by any other services. It can be open it up to your client, and because you have deployed it using Kubernetes, it's a pretty scalable fashion. And auto scaling mechanism is also there. You can the same files that I was discussing here, like deployment and services, you can write some kind of auto scaling YAML file as well. That is also possible, and that can be managed by the customization. And I think yeah, that's it on my side. It was uh, pretty technical maybe. Yeah, thank you so much. Mudit, can you hear me?
Yes, I can hear you. Yeah, yeah, I'm here. Thanks for that presentation. I think that was a pretty um, exhaustive and hands-on one. I'm just checking for any questions that the community has. So far, we haven't received any questions. One of the things that we generally see, by the way, is something which many community members initially come up to ask is how they can practice this thing. If let's say they are not working at a company, how do they practice how to build their hands-on skills on deployments and ML ops side of things? So, what is your recommendation on that?
For practicing, the thing is like you have to keep doing the hands-on, right? You need to do a lot of GitHub repositories, follow the best practices, and try to read as much code as possible. And that is what I do. And yeah, I mean, there has to be some kind of usually goal, like in case of this kind of deployment, what you can follow is like later on I'll push my code to GitHub, and partially it is already there. So simply just clone these kind of things, do it. And since I have used the GKE, which is a Google Kubernetes engine, so you can create a simple, I think they provide $300 free of cost for a few months. So they can do the hands-on for this kind of ML ops. They will understand what I talked about, because this thing is maybe if in the beginning I thought like I'll create some kind of boxes, just try to explain like how the things works. But at the end of the day, you have to do exactly the same thing that has been done by me. So
Hmm.
so that has to be there. So that's the reason I wanted to uh, make it more closer to the person who genuinely wants to implement it, rather than just a theoretical talk. And even if
Hmm.
you have worked a little bit of let's say Kubernetes or Docker before, I think you were definitely able to understand what I was talking about, and you will be very close to my explanation. In terms of practicing, again I'll say the same thing. I think reading, maybe you can follow some of the some blogs or something, but basically hands on is the key. If you won't do the hands on, you won't learn. Yeah.
Okay. And is there a so we briefly discussed various we covered we had to discuss around Kubernetes, Flask, and TF serving. So generally, what a lot of people may understand is that Flask is an easier approach to get started with. Or do you recommend a roadmap to somebody who's just getting started on it? How they can probably a roadmap that they should follow to learn on these aspects? And uh, are there any particular use cases where you would prefer to use a particular set of tools over others, given your experience?
Hmm. Yeah, so for model artifacts, actually, this you can use ML flow. It will give you a kind of a proper version control kind of mechanism of model artifacts. And in terms of serving, you can play around with Flask, or you can play around with FastAPI. The reason behind the popularity of FastAPI is like it provides it provides some kind of asynchronous is by default in it, right? Asynchronous kind of calls. So yeah, I mean you can look around some couple of codes, you'll understand like how FastAPI works, how to wrap up your model into it. In terms of best practices, ideally what people does is into the industries like they have a pretty stable data pipeline, like post I'll say the post model development. So that is being handled by machine learning engineers or data engineers. So what they do is like they might have deployed Apache Airflow or Jenkins or CI/CD kind of pipelines and whatever is available into the market, like some kind of best things. But pretty two things like that I'm aware of is like Airflow and Jenkins is commonly used. And in terms of deployment, Seldom Core is something new, not very new, but it's getting popularity. The reason is like it serves not only TensorFlow but PyTorch and SKLM based models. So you can have an eye on that also, like how to deploy these kind of things. It's also an open source tool. But my recommendation is, yeah, same. Like this is more like post model development stuff. So what you can do is like once your model is ready, your binaries are ready, it's ready to serve. So you have to think about how to automatize the thing in a very seamless manner. It can be batch automation, it can be like real time automation. So for that, considering all those things, you have to think of all these things like whatever I gave into this fast API implementation, that is like a more of like you can say streaming kind of deployment, you can say. Because once it is up, because in Kubernetes, once this deployment and service, so once deployment is up, services you are able to serve to as many people as you want. So best practices are like this. This is one of the best practices that I explained into my presentation as well. Like whenever your model is there, try to containerize it and push it. Of course, you can start with simple Flask or Fast API, but later point of time you have to containerize it and push it on some kind of scalable clusters. If that is the kind of use case your company or your project is demanding.
Okay. Okay. Yeah, I think we are towards the end of the session. First off, I would thank the community. I think because we had a glitch, and I would thank you also for being so much patient in the beginning. I'm not sure we ran into an unforeseen platform issue, but yeah, thank you to all the attendees, and thanks a ton, Avinash, for being so patient and delivering such an elaborate presentation. We I know we had to postpone the previous session due to medical reasons, and you
Yeah.
were so kind to have it this weekend. So I'm genuinely very thankful to you for that. Thank you so much, Avinash.
Thank you so much. Thank you so much, Mohit. And
And
hope we can connect in future. Thank you so much.
definitely, definitely. And also, I think for the learners, I think what we can do is we can post the GitHub links and even the link for your Netlify. I think we can post those for community members to check them out eventually. So I think we'll be updating them on DeFi's page itself on the sessions. So I think you can go and check them out by the EOD. It should be available to you after that. Yeah.
Sure,
Okay.
sure. Maybe I think what else we can do is like instead of taking a lot of things into a single presentation, maybe we can just pick a small problem and try to solve it with the best practices into the industry. I think it will genuinely help for the newcomers who likes to understand data science, ML ops, and model building.
Yeah, yeah, definitely aligned on that completely. Okay, then. Thank you so much. We'll see you soon. And yeah, again, thanks a ton, Avinash, for being with us today. It means a lot. Thank you so much.
Thanks for it. Bye.